Assalamu alaikum dear students. Today's topic is secondary growth in dicot system. Secondary growth occurs in dicot system, gymnosperm system, as well as roots of both gymnosperms as well as dicots. But secondary growth is absent in case of monocots, except few like yucca, agave, Dracaena. In these three monocots, secondary or abnormal growth occurs. Secondary growth in case of dicot occurs in two regions, named stellar region and extrastellar region. And this is stellar, this is extrastellar. The growth which occurs in the stellar region constitutes stellar growth, and the growth which occurs extra in addition to this stellar constitutes extrastellar growth. This growth occurs because of vascular cambium. It occurs with the help of extracellular growth occurs with the help of a tissue called as phallogen or periderm. First of all, it is stellar growth in dicot stems. Stellar growth in dicot stems. Since we know that the vascular bonds in case of dicot stems are conjoint, collateral, and open. Conjoint means in which xylem and phloem are located on different radii. Collateral means having one xylem and one phloem group, and open means having vascular cambium. Now, vascular cambium is primary in origin and secondary in function because it is formed from procambium, and secondary in function because it forms secondary medullary rays, secondary xylem, and secondary phloem. It is lateral meristem because it is responsible for lateral growth or growth in thickness. And this is growth in thickness. The cambium which is present in vascular bonds is called intravascular cambium. Fascicular or simply fascicular cambium. That is like this. This one is intravascular cambium. This intravascular cambium is made up of two types of cells, namely ray initialis and fusiform initialis. Fusiform initialis. Ray initialis form secondary medullary rays, and fusiform initialis form secondary xylem and secondary phloem. Fusiform initialis are like this, long and elongated. Ray initials are small isodiameter, like this. Ray initials are fusiform initials. Now the activity of cambial ring. As the secondary growth begins, the cells which lie in the medullary rays also become active and constitute a cambial strip which is called as interfascicular cambium. Interfascicular cambium. Both intra and inter alternative strips of now intra and interfascicular cambia now constitutes a cambial ring, like this. It is cambial ring. This cambial ring cuts cells towards outer side as well as inner side. More cells are cut towards inner side and less cells are cut towards this outer side. The cells which are cut towards inner side, they constitute secondary xylem, and the cells which are cut towards outer side, they constitute secondary phloem. Secondary xylem constitutes wood. So botanically, secondary xylem is wood. That is, wood is secondary xylem, not secondary phloem, not primary xylem, not primary phloem. It is secondary xylem. The wood is of various types, like it is porous, it is non-porous, it is spring wood, it is autumn wood, it is hardwood, it is sapwood. The wood which possesses vessels in its xylem, it constitutes porous wood. This porous wood is found in case of angiosperms. And the wood which lacks vessels in its xylem, it is called as non-porous wood. It is found in case of gymnosperms. Then the early formed wood constitutes spring wood, and the wood that is formed during leaf fall constitutes autumn wood. This is spring wood, and this is autumn wood. Both spring and autumn wood constitutes an annual ring or growth ring. We can estimate the age of a tree by counting these annual rings. Study of annual rings or growth rings is called as dendrochronology. With the help of dendrochronology, age of tree can be determined. Then there is hardwood, that is like this, which is less active, and sapwood, which is physiologically more active.